4,000 airplanes sitting in a desert, nobody flying them, nobody boarding them, just sitting there in the Arizona sun in lines so precise they look drawn by a machine. From the air, it looks like a graveyard, but it isn't. And understanding the difference between those two things tells you something important about how American air power actually works. Not how it's advertised, but how it survives. This is the 309th Aerospace Maintenance and Regeneration Group, Davis-Monthan Air Force Base, Tucson, Arizona. Everyone calls it the Boneyard. And the name sticks because the place looks like one, but the engineers who designed this facility and the logisticians who run it designed it to do the opposite of what a graveyard does. A graveyard preserves nothing. This place preserves everything. And the engineering behind that choice starts with the ground itself. The Sonoran Desert gets about 12 inches of rain per year. Humidity averages below 20% for most of the year. That number matters more than almost anything else about this location. Moisture is the enemy of aircraft storage. Corrosion, mold, condensation inside fuel systems, oxidation in avionics, all of it is driven by water. Dry air slows all of it. But the site has a second advantage almost nobody talks about: the soil. Caliche, a calcium carbonate-hardened alkaline layer just below the desert surface, is dense enough to support heavy aircraft without paved ramps. That means you can park a B-52, a plane that weighs nearly 500,000 pounds at gross, directly on the desert floor, and it won't sink. No concrete required, no infrastructure cost per aircraft, just land and park. That combination, ultra-low humidity and load-bearing soil, is why the Air Force chose this exact patch of southern Arizona in 1946, and why nothing else in the continental United States comes close. When a plane arrives at the Boneyard, it doesn't just get parked and forgotten. It goes through a preservation process that can take days. First, all fluids are drained or treated. Fuel systems are flushed. Hydraulic lines are purged and refilled with preservation fluid. Engines are fogged with a light oil coating. Every intake and exhaust port gets sealed, not with tape, but with molded plugs. Then comes the part that makes this place visually distinctive from orbit. A white vinyl coating called Spraylat is sprayed over every cockpit window, every sensor aperture, and in many cases, the entire fuselage. It reflects solar radiation. It blocks UV degradation of seals and plastics inside the airframe. The cockpit can reach 250 degrees Fahrenheit on a summer day without it. With the coating, internal temperatures stay manageable. Wiring insulation survives. Avionics don't cook. The white-coated aircraft are the ones in long-term storage. The ones without coatings are active, either waiting for parts harvesting or being readied for regeneration. The facility operates on a 4-tier classification system. Type 1000, short-term storage, aircraft recalled within 90 days. Type 2000, intermediate storage, recalled within a year. Type 3000, long-term, recalled within 4 years. Type 4000, parts source. It will never fly again. That last category is what earns the Boneyard its name. But roughly 80% of the aircraft here are not Type 4000. They are being stored. They can come back. The regeneration process is where the Boneyard's real strategic value becomes visible. When the Air Force needs an aircraft back, the AMARG team starts by stripping the Spraylat. That alone takes a full day. The coating peels off in sheets. Then fluid systems are recharged, plugs removed, engines inspected, avionics are tested, airframe joints are resealed. A well-preserved short-term aircraft can be returned to flying status in as little as 2 weeks. A long-term Type 3000 aircraft might take several months and a deeper depot-level inspection, but it flies. These aren't museum pieces. They're sleeping machines. The numbers behind regeneration are striking. Since 1946, AMARG has returned over 6,000 aircraft and 54,000 engines to military service. That is not a storage depot. That is a manufacturing output, without building a single new airframe. Now look at what's parked there. That inventory is a direct readout of American air power strategy over the last 70 years. The biggest single population at the Boneyard right now is the F-16 Fighting Falcon. Hundreds of them. More than many countries fly in their entire Air Force. They're there because the F-35 has been replacing them in active squadrons, but the Air Force isn't destroying them, it's banking them. Why? Because in a high-intensity conflict, you burn through aircraft faster than any factory can build them. The Boneyard is the reserve bench. It's the difference between a force that can absorb losses and keep fighting, and one that's exhausted after the first month. The A-10 Warthog is another significant population. The Air Force has been trying to retire the A-10 for over a decade. Congress keeps blocking it. The result? Hundreds of airframes in various states of storage, some active, some preserved, some stripped. It's an entire bureaucratic and political argument frozen in metal and vinyl. The C-130 Hercules has been in continuous production since 1954. Multiple variants park here. Some are 4 decades old, some flew in Vietnam. They sit next to C-130s that left active service last year. B-52s occupy their own section. These are the oldest flying airframes in the U.S. inventory, and here, some of the oldest parked. Aircraft that flew in the Cold War, that crews flew over Vietnam, that have been in storage longer than most of the people who now maintain them have been alive. Some will be recalled, some will become spare parts. A few will be cut up under Arms Control Treaty obligations and left visible from satellite. Proof of destruction. That last detail is important. The Boneyard is not invisible. It was never meant to be. Under the Strategic Arms Reduction Treaties, dismantled aircraft must remain on the desert floor for 90 days, visible to Soviet and later Russian reconnaissance satellites. The desert itself becomes a verification mechanism, proof that the cuts were made, the treaties honored. The Boneyard is doing multiple jobs simultaneously: parts depot, strategic reserve, arms control verification site. It is, arguably, the most complex single logistics node in the U.S. military. The parts harvesting mission alone is worth pausing on. Modern military aircraft have extraordinarily long production runs. The F-16 entered service in 1978. The Air Force flew it for nearly 50 years. But manufacturing lines close. Suppliers go out of business. Components become impossible to source on the open market. When an active-duty F-16 needs a specific radar component that Lockheed stopped producing in 2004, the answer might be sitting in Row 47, Aircraft 312, at Davis-Monthan. AMARG maintains a computerized inventory of every component on every aircraft, down to individual circuit cards. The Air Force can query the system, identify a specific part, and have it removed, tested, and shipped to an active squadron in days. AMARG estimates it saves the Department of Defense over $1 billion per year in parts procurement costs. Those aren't abstract savings. They're the difference between operational aircraft and hangar queens. A hangar queen is a plane that sits on a base and can't fly because it's waiting for a part. Every day it can't fly. It's a wasted asset. The Boneyard reduces that problem by giving maintainers a spare part supply that no catalog or manufacturer can match. But there's another dimension to this facility that rarely gets discussed: foreign military sales. When a U.S. ally buys surplus American aircraft, and dozens have from Greece to Taiwan to Pakistan, those aircraft often come through AMARG first. They're inspected, restored to a defined standard, and delivered. The Boneyard, in this role, is a foreign policy instrument. Aircraft that might otherwise be scrapped become alliance capital. Taiwan has received F-16s from AMARG. So has Jordan. So has Indonesia. These are aircraft that were built, flown, retired, preserved in the desert, and then given a second operational life in a different country's Air Force. That life cycle, build, fly, preserve, regenerate, export, is exactly what the Boneyard was designed to enable. Now step back and look at the full picture. What does 4,000 stored aircraft tell you about the strategic assumptions of the United States military? First, it tells you the U.S. military does not believe aircraft should be destroyed simply because they've been replaced. Second, it tells you the planners who built this system expected future conflicts that would require rapid expansion of the force beyond what peacetime budgets can sustain. Third, and this is the one that most observers miss, it tells you the Air Force is thinking about attrition. In a peer conflict, against China, against Russia, Wargame simulations consistently show the US burning through airframes at rates that current production lines cannot replace. The Boneyard is the answer to that problem, already built and waiting. Lockheed Martin's Fort Worth plant produces roughly 130 to 140 F-35s per year at full rate. In a high-intensity conflict, that number is not fast enough. But the Boneyard can return a well-preserved F-16 to flying status in 2 weeks. That calculus matters. There's a philosophical point buried inside all of this engineering. Most countries destroy their retired military aircraft. They cut them up. They sell the metal. A few go to museums. That's the standard approach. The United States, uniquely among large military powers, made a different bet. It found a climate that would preserve aluminum airframes for decades. It built a logistics organization around retrieving them. It maintained that organization through the Cold War, through the post-Cold War drawdown, through the wars in Iraq and Afghanistan, and into the present. The facility grew in every era. Cold War, thousands of B-29s, B-47s, early jet fighters. Post-Cold War, the drawdown flooded the Boneyard with F-111s, RF-4s, A-7s, aircraft retired faster than any plan anticipated. Post-2001, the wars in Afghanistan and Iraq actually drew aircraft out of the Boneyard and returned them to service. Older C-130s, A-10s recalled for close air support. The flow runs both ways. Aircraft move in, aircraft move out. The inventory changes with strategic reality. Today, the biggest change at AMARG isn't the aircraft types, it's the drones. As the MQ-9 Reaper has replaced the MQ-1 Predator in active service, the older drones have begun arriving at Davis-Monthan. The Boneyard is now absorbing the first generation of combat drone airframes at scale. That is a small but significant signal about where military aviation is heading. The next generation of stored aircraft may include stealth platforms. Exactly what gets preserved and how in a world where low observable coatings degrade with time and radar-absorbent materials require climate-controlled storage. That is an engineering problem AMARG hasn't fully solved yet. You cannot park a B-2 Spirit on the open desert for 20 years and expect to recover its radar cross-section. So the Boneyard model, which was designed around aluminum airframes and conventional systems, faces a design challenge as stealth becomes the baseline. That tension between what the facility was built to do and what future air power will demand is the unresolved question hanging over this place. For now, though, the rows keep growing. Aircraft arrive from bases in Europe, the Pacific, and across the continental United States. They get processed, coded, cataloged, and parked. 4,000 airplanes in a desert, not abandoned, stored, not forgotten, cataloged to the last circuit card, not dead, sleeping in the dry Sonoran air, waiting for a call that may or may not come. If you want to understand how American air power actually sustains itself, not through procurement speeches or budget lines, but through engineering and logistics, this is the place to start. If this kind of thinking interests you, there's more on the channel. The next one is already queued.